So let's begin by setting up our project first. I've created an empty Unity project and the project name is Paint, and this should be the starting scene that you will be see. The sample scene is already there. First, we'll change our build settings to Android and take a couple of seconds. And after that, we'll create our gameplay scene. So it should be done in Mhm. So our platform is changed to Android now, and we'll remove our sample scene from the build. The scripts are compiling. Basic for 10, 12. So our platform is changed to Android. We'll remove our sample scene from the build, create a new scene, and we'll save the scene inside our scenes folder as a gameplay scene, and we'll add it to the build. Now let's go to the project settings, and inside our TextMesh Pro, we'll install the TextMesh Pro Essentials, and let's disable the warnings. And for our editor, we'll use the naming convention to use underscore. And now we'll set up our packages. So we'll remove all the unnecessary packages, and after that, we'll start adding our assets. So we need the Visual Studio editor. We'll update it. We don't need the VS Code editor. So let's remove the VS Code editor. We also don't need the version control and the visual scripting. So it is removing version control. We'll also remove the visual scripting, and we also don't need the test framework. So everything should be removed. And finally, we'll update our timeline. So it will take a couple of seconds and everything should be done. So let's close the build settings and the package manager. It is updating. So it is updated. It is going to recompile all the scripts and let's also close the packages. And instead of game, let's use a simulator. Now we need to bring in our assets. So we need the editor and the resources folder. The editor folder contains the color palette, and the resources folder contains our sprites. And this is the color palette I'm going to use. And let's create the rest of the folders. So we need one for our prefabs, and we are going to have one more for our scripts, and finally last one for our generator. And we'll create our level generator scene. So we'll create a new scene and we'll save the scene inside our generator, and we'll call this level generator. And let's create our script. So the first script we are going to need is a level, which is going to be a scriptable object, and we are going to have the game manager. And after that, we are going to have the player, and finally our block. And we are also going to have a script for our generator. So we'll rename it as not rename, create it as level generator. And that should be it. Now let's go inside our gameplay scene and let's start creating our prefabs. So let's start creating our prefabs. Let's first change the color of our main camera to pure white, which is the lightest of our color palette. And after that, we'll create our block. So our block is just going to be a simple sprite renderer and with a block sprite. And it is going to be at the background, so its order in layer is going to be set at 0. And the sprite we are going to use is our pixel sprite. And for now, let's use the orange color which we have, and for the darker one we are going to use the light color, and blocks are going to be the black color, and it's always going to be at 0th order layer, and we'll change its size to 0.95, and we'll save it as a prefab. Now let's create our player, and it is going to have a sprite renderer which is going to be our circle, and its color is going to be black, 48.5, 15, and the size it's going to be zero point 0.8, and its order layer is going to be 10, and we need to attach our player script, and it's going to have one more empty again, which is going to have a sprite renderer. The sprite is going to be the circle, ordinal layer is going to be 11 instead of simple, the size is going to be 0.4, and the color we are going to use our orangish color. So this is going to be a player, and after we have our block and the player, let's create our game manager, and we'll attach the game manager script. And now we need to start creating our level. So we need to create it as a scriptable object. So let's go inside our first script, which is going to be our level. So it is going to inherit from a scriptable object, and we are going to create the asset menu with the file name of level and the menu name of level. And inside the script, what are we going to need? So we are going to need the row and the column. So it is going to be public int row, public int col, and public vector to end, which is the starting position, and public list of integers, which is going to be data, and it is going to store the data wherever it is blocked, and we'll remove the system.collections. Now let's go inside our block. It is going to have some simple functions. So there is going to be just one initialization and one filling function, and nothing else. So we are going to hide an inspector, public pool of block, and hide an inspector, public pool of field, and serialized field, private sprite renderer, and we'll just call it block sprite. Serialized field, private color for our block color, serialized field, private color for our empty color, and serialized field, private color for our active color. And did I change? Yeah, I did change. And after that, we are going to need our initialization function. So public void init, and we'll pass the int of fill, and our block is going to be if our fill is equals to 1. So 1 is going to be for the block, and our field is going to be blocked. If it is blocked, then it is going to be filled, and our block sprite dot color is going to be, if we are block, then we are going to have the block color as it is going to be the empty color. And one more function which is going to be add, which is just going to set fill to true. And our block sprite dot color is going to be our active color. So pretty simple functions, nothing too complicated. And after that, we will create our scriptable object. So let's go inside Unity. And for now, inside our prefabs, let's create the level. And it is just going to be called level. Let's use it 3 cross 3. Starting position is going to be 0. And it is going to have 9, and the fifth element, which is going to be element 4, is going to be 1. So it is going to be blocked, and we are going to have a 3 cross 3 grid with just the center position block, and rest of the grid will be open to move. So this are the prefabs, and after that we'll start spawning our prefabs. So we created all our prefabs. Now we need to spawn our prefab and position our player. So we need to start with the game manager, and let's create our game manager instance. And after that, we are going to have hidden inspector, and it is going to be a public boolean, which is going to be can click, and it's going to be true at start. And after that, we are going to have serialized field, private level, and serialized field, private block prefab, and serialized field, private player, and it is going to be our player. And after that, we are going to have a private block 2D array, which are going to be our blocks, and our private vector 2 for the start and the end, and a private bool for has game finished. And if our game has finished, let's go inside our awake. Instance is going to be this, has game finished is going to be false, can click is going to be true. And after that, we'll spawn our level. And let's create our function for spawning the level. So we'll first set up the camera position. So campos.x is going to be level.column multiplied by 0.5 minus 0.5, and campos.y is going to be level.row multiplied by 0.5 minus 0.5. And let's rearrange everything. And after that, we'll set our camera's position, camera, and we'll set our camera size. So camera dot main dot orthographic size is going to be mathf dot max of our level dot row and level dot column, and we'll add 2f. And after that, we need to initialize our player, and we need to pass the starting position, which is going to be level dot start. And after initializing our player, we need to spawn our blocks, and the x and y size are going to be row multiplied by column. So we are going to have number of rows and number of columns. And after that, we need to spawn them. So for int I is equals to 0, I less than level dot row, and for int j is equals to 0, level dot column, blocks of ij is going to be equal to instantiate, and we are going to instantiate the block prefab at new vector 3 of jin 0, row to xy coordinate at quaternion dot identity, and we need to initialize them. So blocks of ij dot init, and we need to pass our value, so level dot data of I multiplied by level dot column, that is going to be the row size, and we'll add j, and that should be it for the spawning. And inside our update, if our game is finished or we cannot click, then we are going to return. Let's create our game finished and private void check win. So for checking the winning condition, we'll check all of our blocks, and if our blocks of ij is not filled, then we are going to return. Else our has game finished is going to be true, and we are going to start the coroutine, which is going to be our game finished. And inside our game finished, we are just going to restart the game. So private enumerator game finished, and we'll wait for 2 seconds. You return new, wait for seconds, and we'll pass to F. And after that, we'll restart the game. Unity engine dot scene management dot scene manager dot load scene, and that is just one scene, so we'll pass this 0. And now let's finish our errors. So our player does not have the initialization. We need to set the initialization for our player. Block has the initialization, so there is no error there. And do we need where is our game manager? So we are not going to need the collection dot generic, so let's remove that too. And let's go to our player. We need to initialize it. Let's create an hidden inspector public, and we are going to pass the vector to ends of our position, and serialized field private float for our move time, and serialized field private animation curve, and we'll just call it speed curve. And let's go inside our init public void init, and we'll pass the vector to end of our start. Our position is going to be the start, and transform dot position is going to be new vector 3 of pos dot y comma pos dot x and 0. And after that, we are going to need the movement function, so it is going to be a coroutine, and we'll just call it move. We'll pass the vector to end of offset and integer of distance, so how many units we are going to move. So first we'll change the position, and after that we'll calculate the total time, and it's going to be equal to mathf dot abs of distance. So sometimes the distance will be negative, and we'll multiply it by the move time, and our speed is going to be 1 divided by move time, and not move time, 1 divided by total time. And after that, our time elapsed is going to be equal to 0f, and what we need to get is the start position, which is going to be transform dot position. Vector 3 end position is going to be new vector 3, and we'll pass the pose dot y, pose dot x, and 0f, and we'll create the offset position, and it's going to be equal to end minus start. Now, while our time elapsed is less than 1f, so we are going to scale it as 0 to 1. Our transform dot position is going to be start distance, start position plus our offset position, and we'll multiply it by speed curve dot evaluate our time elapsed. And after that, we'll increase the time elapse. So time elapse plus is equals to time dot delta 9 and speed. And after that, we are going to wait for 1 frame. So we'll use the return null. And we need to get the x and the y coordinates. So we need to highlight it. So int x is going to be equal to mathf dot floor of floor to end of our transform dot position dot x and plus 0.5, and similarly into y transform dot position dot y plus 0.5, and we need to highlight our block. So game manager dot instance dot highlight block, and we'll pass the x and the y, and we need to create our highlight. So let's go inside our game manager, and before our game check when, we are going to create our highlight. Mhm. So public void highlight block, and we are going to pass the int x and the y, and inside our highlight block we'll pass the y and the x dot add, and we are going to call the function from our player. So there are not any issues, and game manager dot instance and everything else is ended. We need to change the ending position, so it should be transform dot position is going to be the end position. Game manager dot instance dot can click is going to be equal to true, and game manager dot instance dot check when, so it needs to be public instead of private. And let's go inside our player, and we are going to check the winning condition, or our winning condition will not be detected until the next movement has occurred, because inside the update it is going to check at the original frame, and this is going to move, and at the end of the movement it is going to check, and everything would not be highlighted at the start. Only when every position is passed, the blocks will be highlighted. So we added the check when the initialization, and there should not be any more errors. So let's see if anything's remaining. So our player is done, and we'll add it to our finished scripts. And for our block, we just need to set it up. And inside our game manager, we initialized everything. And was anything remaining? Camera, player, and blocks? Yeah, nothing was remaining. So let's go inside Unity and let's set up all our variables. So our block is going to have the sprite render attached. Our block color is going to be the black color. Empty is going to be the light gray, and the active one is going to be our orange. And similarly for our player, move time is going to be 0.1. And move curve, let's use the speedy one. Let's go inside our game manager. We need to attach the level, the block prefab, and our player, which is inside the scene. So let's hit play. Let's see if everything's done correctly. So as you can see, we are able to see our scene, and this is the starting spawning conditions depending on what we passed inside our level. So in the next part, we'll see how we are going to move our player by getting the input, and the winning condition is already added. So the game should be finished when we have filled everything else. So let's go to the next part. So in the previous part, we spawned all of our prefabs. Now we need to update the movement. So whenever you click and drag, it should move in the respective direction. So let's go inside Visual Studio and let's add our scripts. So first we are going to add a couple of functions. So first one is going to be private void is valid. So when a grid position is valid, and we are going to pass the vector to int of position, and we are going to return if post.x is greater than equal to 0 and post.y is greater than equal to 0 and post.x is less than level.row and post.y is less than level.call, and instead of void it is going to return a bool. And after that, we are going to have one more function, which is going to be private vector to integer, and we'll call it get direction. And depending on the starting and the ending position, we are going to get the direction. So vector 2 offset is going to be equal to end minus start. And if mathf dot abs of our offset.x is greater than mathf.x of offset.y, then we are going to return if x is greater than 0, then that means our row is going to be get changed, and x is okay, the column is going to get changed and we are going to move to the right. So it is going to be up cause the right as the column increased, and this is going to be the down. And if it is not, then we are going to return offset.y is greater than 0. That means we are going to move to the right, and if it is less than 0, then we are going to move to the left. So it should be getting the directions, and after getting the directions, we need to get the end position. So private vector to integer, and we'll call it get end position, and we need to pass the direction. And let's create our result, which is going to be our direction, and our checking position is going to be equal to player dot position plus our result, and while is valid our checking position, and our checking position is not blocked x and the y. We are going to add to the result. So result plus is equals to direction, and our checking position plus is equals to direction. And after that, we are going to return our result minus direction. So we just need the offset, how much we need to add. So get end position, we can just directly call it get offset position. I named it get end position first, but it should be called get offset position. And whatever value is there inside the x or the y coordinate, that's going to be the distance. So if there's 1, 2, or 0, then that's going to be the distance. Now, inside our update method, if we are pressing Then we'll update the start. So vector 3, our mouse position is going to be camera dot main dot screen to world point, and we are going to pass the input dot mouse position, and we'll set the start to be equal to new vector 2 of x and y. And similarly, we are going to update the end else if input dot get mouse button of 0. Then we are similarly going to update the end. Instead of start, we'll update the end. And finally, if we release it, so else if input dot get mouse button up of 0. Then we are going to get the direction, and after that we'll get the offset, get offset position, and we'll pass our direction. And if our offset is equals to 0, then we are going to return else. We are going to start the coroutine, which is going to be player.move, and we need to make it public. We need to pass the position, which is going to be the offset, and offset.x is equals to 0. Then we'll pass the offset.y, else it is going to be offset.x. And we'll set the can click to be false. So can click is going to be equal to false, and that should be it. So we'll get the direction, and after getting the direction we'll get the offset, and we'll move the player by that offset, so it is directly going to change its position and highlight all the blocks. And till the coroutine is finished inside our player, our can click is going to be false, and at the end our can click is going to be true. So pretty simple, nothing too complicated, and it should work. And let's go inside Unity and let's move. So as you can see, the game is finished and it is going to restart the scene. And it is moving in the all four directions. And that's it for our gameplay scene. So again, it was pretty much easy as we already created 9 games before, and we already know how the functions are going to attach to be attached, and what functions are we going to need. So there are not any unnecessary testing. So what variables are we going to need? So that was it for the gameplay scene. And the next part will create our level generator, which is going to be again pretty simple. We just need to set each of the values to be 0 or 1 and change our player's position. So let's go to the next part. So in the previous part, we created our core gameplay loop where we have to move through these blocks and paint every block. And in our current part, we are going to create our level generator where we are going to edit our level. Let's create our player prefab and let's start creating. So again, it is going to be similar to the initialization function. So let's go inside Visual Studio and we'll copy our game manager and we'll paste it inside our level generator. And we are not going to need the instance, no need for can click level blocks we are going to need has game finished, also not needed. Level spawning conditions are going to be similar. We are not going to need any of the update methods, and we are not even going to need the direction and the offset. We'll just have the is valid, and highlight we are not going to need, and everything else is going to be removed. So we have the spawn level function. And before that, we need to create our level. So if we are going to create a new level, then we need to add it. So private void create level. And when are we not going to create it? So if our level dot row is equals to row, and our level dot call is equals to call, then we are going to return, and we need to create our rows and the columns. So serialize feed private integer for our row and call, and if it is not, then we are going to set the level dot row to be equal to row, level dot call to be equal to call, and level dot start to be equal to 0, and we'll use a for loop, and we are going to use the row and the column. J is equals to 0, j less than level dot column, level dot data dot add, and at start everything is going to be blocked, and we need to initialize our data. So it is going to be newlist, and we need to save the level. So editor utility dot set dirty, and we are going to save the level. So it is just directly going to initialize everything, and inside our update, we'll check if input dot get mouse button down of 0. Then we are going to update our block, and if input dot get mouse button down of 1, so then we are going to update our starting position. So let's update our block. So let's first get the mouse position, and it is going to be camera dot main dot screen to world point of input dot mouse position, and let's create a vector 2 int of grid position, and it's going to be a new vector 2 int of mathf dot floor to int of mouse pose dot y, and mathf dot floor to int of mouse pose dot x. So it is going to be converted to a grid position, and after we have the grid position, we are going to check if it is a valid grid position, then we'll return. Not valid, then we are going to return. But if it is a valid grid position, then we'll get the current fill, which should be from the level dot data, and level dot data, and we need to pass the grid position dot x multiplied by the column plus our grid position dot y. So it is going to be our current fill, and we'll change our current fill's value. So current fill is going to be equal to, if it is 1, then we'll set it to 0, else we'll set it to 1. 1 0 and 1, and we'll update the data. So we'll set the grid post dot x multiplied by column plus grid post dot y is going to be the current field, and we'll initialize our current field. So it should be for the blocks of I and j dot init. Mm, mm, int I is equals to grid post dot x, and j is equals to grid post dot y. So now it won't show errors. And after that, we need to save our level. So editor utility dot set dirty. Mm, and we are going to pass our level. And similarly, if we are pressing the, let's copy the whole script again. So if we are pressing down the mouse button one, then we'll get the grid position. Instead of doing everything else, we are just going to set the position. So our level dot start is going to be our grid position, and our player dot init is going to be our grid position. So that should be it. Yeah, nothing too complicated. We just need to add it to functions where we change the values inside our scriptable object and initialize it again. So it is already instantiated. We don't need to do anything. And let's delete and let's go inside Unity and let's see if everything's done fine. And let's create a 5 cross 5 level, and we'll add the level, add the player, and add our block. Now let's initialize it. So it should create as a 5 cross 5 level, which is going to be blocked. And nothing is working. So there is problem with input dot mouse position. So screen to world point and screen to world point, mathf dot floor to end. Okay, and we need to subtract 0.5. So did I subtract 0.5? Okay, I need to add 0.5. So let's go inside Visual Studio, and we need to add the 0.5. And similarly, we need to add here. Yeah. Now let's go inside Unity and let's see if it did solve. So first, let's check if our player is moving. So our player is not moving, but we are able to click. So we are able to click. Now let's create. Hmm. Yeah, looks like a skull. And we need to update the player's position, but it is not getting updated. Why is it not getting updated? Is it not initialized? Let's go inside Visual Studio and input dot get mouse button. If it is not valid grid position, then we are going to return. Level dot start is going to be grid position, and player dot init is going to be the grid position. So it should have been updated. Mouse button down, input dot get mouse button down. Camera dot main dot screen to world point. So it is not valid. Less than row and less than call. Let's check again. Yeah, I know why it is not getting clicked. So the mouse clicks only work inside our Unity editor. So that was the problem. Now let's go and add, and we can add like everything. So this is going to be a level editor, and this should be saved. And we should be able to play it inside our gameplay scene, but didn't delete the sample scene. So let's delete it and let's play inside our gameplay scene. So we are going to move up, down, left, right, and now the game should be finished and it is going to restart the scene. So this is our paint game, and this mechanic is like used multiple times. There was stacky dash and color paint. So that was just the basic core logic for the game, and you can like create 20 to 30 multiple levels, create your own game, and publish it on Play Store. And thank you guys for watching.